So kindly confirm, am I audible to everyone?
Yes, sir.
Yes, sir.
Noise.
Yes, sir.
Still yes.
Yes, sir.
The webinar is live on Microsoft Teams. Please join Microsoft Teams.
So is my screen visible?
Yes, sir.
Yes, sir.
Okay, so good evening to everyone. My name is Manshu and I welcome you all to this webinar. So today we'll be talking about the battery packs. So we'll be discuss about the different parameters, the different form factors of the battery, as well as I will show some simulations related to charging and discharging of the battery on MATLAB. So today the agenda, at first I will talk about the different types of battery, like what are the different types of battery, like primary, secondary. So we will also talk about the different nomenclature of that. Then we'll be talking about the different components of the battery, like what are the different components of the battery by which they are made, and also that after that we'll be talk about different form factors. So I will be discuss more about
Voice is very low. Can you increase your volume, please? Hello.
yeah.
Can you increase your volume? We can't hear you.
Is it audible, sir? Is it fine?
Yes, yes,
Hello?
yes, sir. Yeah.
Yes, sir. His voice is okay.
Okay. And after that I will be talk about the different form factors of the battery. Then I will do the comparison of the different battery characteristics, like the different nominal voltage, like what is the difference in the voltage level of the different nomenclature. Then I will be talking about the battery terminology, what are the different parameters upon which we do the calculation. Then we'll be talking about the designing, like on upon which factors the designing and the designing of the battery depend. Then the steps. Then the step I will be talking about the different steps upon which the battery pack is being designed. So first, the first one is the different types of battery. So So the first is the primary batteries. So primary batteries are those batteries which cannot be recharged. So once their chemical properties being exhausted, they needed to be replaced. So this battery cannot be recharged. So example of that are alkaline batteries of zinc, magnesium oxide and carbon, the aluminum air batteries, the dry cells and the zinc carbon. Now talking about the secondary batteries. So secondary batteries are the batteries which can be recharged once they can be used again and again by recharging. Once their chemical capacity is being used, like we discharge the battery and again we can charge the battery. So different chemistry of these secondary batteries are, the first one is the lead acid, then the nickel cadmium, the nickel metal hydrides, and the lithium ion batteries. So these batteries are used in electric vehicles because of their recharge because they can be recharged again and again. Now the kindly everyone mute. So now I will be talking about the different components of the battery. So from this diagram we can see the electrodes. So electrodes are the anodes and the cathodes only, and this electrolyte and the separators. So the electrodes and so in the different chemistries of the battery, the anode and cathodes are made up of different elements, and the separators are used to separate the electrolytes and the anodes and the cathode in the battery. So here we can see the exploded diagram of a battery. So we can see here it is the steel plate. This is the positive part of the battery, and apart from this, all of these are the negative part. So we can see the entire construction of the battery. Like here we can see this is the cathode. So this part is the cathode, which is so this is the cathode, and which is made up of magnesium dioxide, carbon or electrolyte. And this is the steel can, the anode gel. We can see different part of this battery. So this is the bottom part of this battery. So this is the entire, or we can say the inside. We can say this is the inside constructions of the battery. Okay. So now the talking about the different form factors. So first one is the cylindrical. So as the name, so cylindrical battery form factor is this one, and this one is the prismatic, and this is the pouch. So so can anyone from the participants can differentiate between like what is the what is the difference between cylindrical, like what are the disadvantage or advantage between the cylindrical and the prismatic cells? Like apart from this those things this is displayed on the screen, apart from that, in terms of thermal management or anything. Yes.
The cost will be more and design complications.
Yeah, in which this one or this one?
So in the cylindrical it will be cost will be more less because it cannot store more amount of power.
Yeah, but here I am also mentioned that cost of this pack are low. So apart from this, like in case of thermal management, or you can say space usability. So in those way, can you explain?
In pouch type cells increase his size after some time.
Yes, yeah, I didn't heard that.
Like like mobile cell phone battery.
Okay. Yeah. That these are using mobile phones there. So here this is the cylindrical and this is the prismatic. So the main advantage of this cylindrical is that we can because if we see the cylindrical structure from the top view, so we can see like cylindricals are placed in this way. So we can see here caps. So this cap can be used for cooling purpose. Okay, so but also there is a disadvantage that this by using the cylindrical configuration we cannot utilize the fully space. So there is a disadvantage that there is no proper use of space. There are some space left between them. So but in case of prismatic cells, we can see due to their constructions are in square form, or we can say rectangular forms, the space, there is no space left behind. So this is the advantage or disadvantage we can say between the cylindrical as well as the prismatic cell, and this one is the pouch cell. So here are the. Okay, so can anyone tell me, like, cylindrical cell or prismatic or pouch, which one will have AH rating more high? Like AH rating, I will be explaining that what is AH rating. So
Prismatic cells.
Ampere per hour.
yeah, prismatic cells have higher AH rating.
Yes.
So now there is a comparison of battery characteristic. So I have listed the different chemistry of the battery. So here you can see this is the lead acid battery and the nickel metal hydride, the lithium of different nomenclatures. So first one is the cobalt, manganese, and the phosphate. So talking about the difference between the specific energy density. So we can see that the energy density of lead acid battery. Yeah, anyone is saying something?
I don't know now.
Kindly everyone mute.
No, inside. H8.
Hello?
Not too much thing. No, nothing. This is.
Please on.
Okay, take 3.
Please mute your mic.
Take.
So, different specification of the battery. So this one is the lead acid battery and nickel metal and the lithium of different nomenclatures. So first I was talking about the energy density. So energy density means that the like whatever, like energy stored per unit kg, like how much energy is being stored in 1 kg. So we can see here this is lead acid. So it has specific energy and density of 30 to 50, and then we can see this is nickel metal hydride. So we can also see the energy density, like it ranges from 60 to 120. So lead acid battery and nickel metal hydride. So we can see nickel metal hydride have more specific energy density as compared to the lead acid. Now when we talk about the lithium ion, so lithium ion batteries, we can see the specific energy is even more better as compared to the nickel metal hydride. So it ranges from 150, hundreds or to 190 of the cobalt nomenclature. Now talking about the cycle life. So cycle life, what is cycle life? Can anyone explain?
Charge and discharge.
Yeah, the complete process in which we can charge the battery and discharge the battery. So first is the cycle life. So lead acid battery has 200 to 300 life cycle, and nickel metal hydride has the nickel metal hydride has 300 to 500. And talking about the lithium ion batteries and lithium ion chemistry, so we can see it ranges from 500 to 1000. So the cycle life of the lithium ion batteries are even more better than lead acid and nickel metal. So now the 3 voltage. The first one is the cell voltage of the battery pack. Okay, so this one is the nominal and the cutoff, charge cutoff, and the discharge cutoff. So I'm asking from audience, like, what do you understand by nominal? Like, what will you guys understand by the nominal?
Means normal voltage.
Yeah, like we can say the voltage which the battery try to maintain for a like it is available for that time. So we can see from this curve. Okay, so this is the cutoff lower charge, and this is the voltage ratio of the voltage curve of the battery. So we can see this part, like it will be straight slightly, it will be increasing. Okay, and so this part is known as the nominal, and this one will be the upper cutoff, we can say, and this one is the lower cutoff. Like if the battery voltage reaches at this voltage, so the battery should be disconnected, and if the battery voltage reaches at this lower point, so the battery should not be discharged below it, otherwise battery will be going to deep discharging. So from the table we can see, like for lead acid battery, the nominal voltage is of 2 volt, nickel metal it is of 1.2, and for lithium ions and the lithium ion batteries we can see it is 2.6 to 3.8. So we can see how changing the chemistry we can see the different voltage level. Okay, is that clear?
Yes, sir.
So also, yes. Any question?
No, sir.
Okay. Okay, we'll discuss solution. So this one I was talking about the nominal, and this is the charge cutoff. So we can see of the lead acid battery. So this one will be the nominal voltage, and the charge cutoff voltage here it will be of 2.40 volt, and this one will be 1.75. Okay, so this one was lead acid, and for similarly for nickel metal hydride, this one will be 1.2, and this one higher one will be 1.5, and this one will be 1. So we can see the comparison of we can even make this curve of the lithium ion batteries of cobalt, manganese and the phosphate. So here is also the timeline, like when initially the lead acid batteries it was started in by the late 1800s. This lead acid battery was in use. The nickel metal hydride battery came into use in 1990s, and the cobalt and the manganese and the phosphate. So we can see here came in 1991 and 1996. Yeah.
Hello?
Hello.
Sir, in lead acid batteries, how it is charge cutoff is charge cutoff voltage is 2.4.
Sir, like he was saying, like why it is 2.4?
Yeah, why it is 2.4? Because I tested it is
Because
for
actually the thing is that now when you start charging the voltage, charging the battery, so it should not be go beyond 2.4 voltage, because after that the battery may. Yes.
actually, sir, I tested for the standard national international ISIEINDIA standard. In those, they are mentioned only 2.25 or 2.3. They are not.
So I have taken 2.4 because according to the chemistry of this lead acid battery. So after that, like some after testing, or we can say this chemistry of this lead acid battery, there will be some effect of like cause the battery damage if we charge beyond the 2.4 volt. So we can say that it should not be go above the 2.4.
So we can charge up to 2.4, right?
We can, but actually what happens when the battery start charging the battery, it should be going from 0 to 100%. Okay, so when we start charging,
And also
After 2.4, temperature increase and maybe expose this battery. So this level is important, right?
Yes, I was coming toward the temperature part only. So if we start increasing, like there will be temperature increase, and then the battery may burst or we can burn. So that's why we have to maintain till 2.4 volt, and the lower cutoff should be 1.75. 0.75. So beyond this one, we should not go, as because the battery may go into the deep discharge. So this one was about the charging cutoff and the discharging cutoff. Okay. So can I proceed?
Can you repeat, sir? Specific energy density?
Yes, sir.
Yeah, it's specific energy. Okay. Okay. So for specific energy means that suppose and like how much energy stored in 1 kg. Like if I give you a lead acid battery, okay, and I give you a lithium ion battery. Suppose this one is lead acid and this one is the lithium ion battery. So I am providing you 1 kg lead acid and this one also 1 kg. Okay, so we can see this 1 kg can store approx 50 watt hour, and 1 kg of this, let's take this one lithium ion can keep 190. Take it. So when you see, I have taken 1 kg of lead acid battery and 1 kg of lithium ion battery. So in which chemistry I will be having more energy? Like A or B? B. So that's why the battery which we are using in electric vehicles have higher energy density because of this thing. So we can charge more energy in a specific way. So if I take, suppose I take 1 kg of lithium ion batteries or 1 kilo of lithium ion battery. So if I take 1 kilo of lithium ion batteries, I will be having more energy as compared to the 1 kg of lead acid battery. I hope you are able to understand. Yeah, kindly confirm.
Yes, sir.
Okay. So now the different terminologies. So of the battery, first one is the capacity, the energy stored, the state of charge, and the depth of start and depth of discharge, the energy density and the power density. So first the capacity. So it is the AH rating of the battery and state of charge, which is SOC. So AH is the ampere hour rating of a battery. Suppose I gave you a battery 1865050. It is a cylindrical cell. Okay. So this battery will have some specification like 3.7 volt and 2.5 Ah. So this is the specification of 18650 batteries. So AH means that how much ampere, like 2.5 ampere, this battery can deliver in 1 hour. So AH means this one. If it is written 2.5 AH, so it means that 2.5 ampere current this battery can able to charge or discharge through it. So this now second one is the energy stored. So if I this one is V voltage and this one is the A. So if I multiply V into A into H, so it will be energy, like V into A is VI is watt and AH is energy. So from here we can see that if we multiply these two, so we will get the energy stored of a single cell, like of 18650 of this battery. How much energy is being stored into this battery, I can get that. Now SOC, so SOC is the state of charge. So anyone have any idea of SOC? Yes.
No, sir.
State of charge. Yeah, I didn't get that.
Means how many power available in cell.
Yeah. Like our battery, it shows like percentage, na, like 100% or 90-50%. So it represents that SOC of the battery, like this much percentage of battery load is remaining into the battery, and DOD of this DOD, that is depth of discharge. This means that like it is the DOD is like how much energy,
How much percentage of discharge it could be done?
yeah, how much energy is being used. So that is depth of discharge, and energy density. I like before assembly of the cells. So first, what we do some energy calculation, and then I will first explain like what happens inside. So initially there is a cell selection, then cell positive side insulation, like we select the cells, like which chemistry of the cells we will be using, then we will be deciding the positive side then we proceed to the insulation part, then cell assembly holder, cell spot welding, which means that we are connecting the cells in series or parallel combination according to that. Series and parallel combination, then we go for the welding check, then soft battery pack assembly, then we go for the current flow check, then insulation check, and the discharge test, and we generate the serial numbers, and then the battery go for the final packing. So I will be explaining like how the first cell selection is being done, like series parallel combination, how we get that, and then we will be like in series, what happens when we connect the cells in series, what happens when we connect the cells in parallel, and then after the cell selection, then this process happens, and then the final battery packaging is being done. So in the coming slide, I will be showing some example like how we describe the battery pack assembly. So now moving to the next slide. So designing of battery depending upon the following factors, like what are the different factors upon which the battery pack designing of the battery pack depends. So first one is the cell configuration, in which I told a series and parallel combination. And so talking about the series combination, so what will happen, so let's suppose this is the battery, this is the positive terminal, and this is the negative terminal. So in series combination, so the control part is also very important. So according to that, the battery pack is being designed. Then the last one is the safety. So the vibration shock abuse, crash, short circuit, thermal runaway, and thermal management. So these things are taken into the consideration to make the battery pack designing fine. So I hope you are clear with it.
Yes, sir.
Okay, so I will proceeding. So these are the steps, like steps for designing battery pack. So here is the step. So one by one I will be discussing. So first one is the calculate the number of cells connected in series in a string. So I already discussed in the previous slide, like to get the 200 volt, okay, and I have one cell of 5 volts, so I have connected 40 in series and 10 in parallel. So initially we'll do the calculation like that, and then and we'll be making a string. Okay, so the first one is the calculate number of cells connected in series in a string. So single cell, how many single cells are connected in a string? So the battery connected in series make a string. Okay, then we will be finding the energy content of that particular string. So how we will be finding is that when number of cells, suppose n number of n number of cells is being connected in a series. Okay, for energy, what will we do? We will calculate the energy of one cell, and then we will be multiplying with the number of cells. Then we will get the overall energy content of a particular string. Then the total number of string in a battery. So, like I want to design a total number of battery pack energy, and it is divided by the energy of a particular string. Suppose after the calculation, I designed a vehicle, and after that I know that this much of energy I require. So we have the data at first. Then what we will be doing? We will be dividing the total battery pack energy which we required, and then we divide it by the energy of a single string. Then coming for the capacity. So now for capacity calculation, battery pack capacity, what we do? We simply calculate the number of strings. So the string was the single, like we connected the cells in series. Okay, so this make one string. So now same thing, this one will make a second string. So now the battery, for calculating the AH, what we do? We calculate the number of string and the capacity of a single string, or we can say here it is representing the parallel combination. Then the string peak current, like what we happens, there are like this way. In battery current there are sometimes peak current demand, and this one is the continuous demand. So what we do, we calculate the peak current also. So this C rate is being available from the data sheet of the battery. Suppose we buy a battery, we have that particular data sheet upon which the C rate, the peak C rate is being mentioned. Then we calculate the battery pack peak voltage. So it's the formula, it is the V and the voltage and the multiplication of this peak current. Okay, so which we calculate here. Then we calculate the string continuous current. So this continuous C rate is being mentioned on the data sheet of the battery. Then we calculate the battery cell capacity, that is AH. This way. Then battery pack continuous current we also calculate. So string continuous current into the well and battery cell capacity. So this is how we calculate the battery pack continuous current, and the battery pack continuous power we calculate by multiplying the continuous current and the battery pack voltage. So these are the steps which we are performing in calculating the battery pack. So I will be having a like small example, we can say. So try to So what I am doing, so I will be doing a battery pack calculation for EV as per the requirement. So suppose if I have this basic battery parameters, so I will be giving, and then will be proceed step by step like what we are doing. So basic battery parameters, cell voltage, AH rating and the C rate. Okay, and the second one is the factor taken into the consideration. Suppose now here what I am doing, I am taking a motor of power 100 watt and the 60 volts, and the gross weight of that vehicle is 250 kg, and the top speed is 50 km, and expected range is 200 km. So this is my requirement, like I have to design a vehicle. Okay, so in which I am using a motor of power 1000 watt, and of voltage, that the voltage of that motor is 60 volt, and the weight of the particular vehicle is 250 kg, and the top speed I will be maintaining is 50 km per hour, and the range I am expecting that it is 200 km. So first what we do, we calculate the ampere like current which is needed by our motor. So for that, what we will be doing, we will be the motor capacity. So what is the motor capacity here? Like at first I am calculating the current which is required by our motor. So everyone is comfortable that what I am trying to do here?
Yes, yes, sir.
Okay. So kindly cooperate. So tell me like how much ampere my motor is required.
1000 watt, no?
1000 by 60 volt.
No. How much? So it will be around
16.66.
ampere. Okay. So this much ampere current I require. Now what happens when we accelerate? So there is some extra current required. So for that I am expecting that 5% of this value will be more. So what I will be doing, I will be adding the 5% of this one. So what I will do, I will simply for 5%. So everyone is comfortable with this? What I did? Like
Yes.
5% of this one, I have added. Like I required at least 70. How much it is? 17.4 ampere.
Near it.
Yes, say. Yes, say.
No, continue.
Okay. So now what I am doing, now I will be calculating the power required at 50 km. So what is the voltage and what is the current?
Voltage is a 60 voltage. Sorry, 8. And power is a 17.
Power of current.
Sorry, current.
Correct. So it will be near about what?
1044.
Yeah. 1040 or 1050 as you will. So my power requirement is here of 1050 watt. Now the second one is the travel factor. So travel factor is nothing but the distance and the speed. So we can say that how much distance we are traveling. It is 200 km and at the speed of 50 km. So it will be 4. So 4. So now the power required to travel. Yes. Yes. Okay. Was anyone saying anything?
Yes, sir.
Okay. So now I required a power of now. So I got a travel factor of 4. So for traveling, how much? 200 km at the speed of 50 km. So I required. Sorry, not 200 km. So now the power, initially I got this power. Okay, so which one is 1050 watt? Yeah. So for power required to travel 200 kilometers. So what I will be doing, I will be simply multiplying this power 1050 to the travel factor which I calculated here. So what will be? It will be 200.
Around.
Yeah. It will be around
4 kilowatt.
Yeah, 4 watt. Now there will be some efficiency of the motor as well as the battery. So let us assume I am taking 85% efficient this battery and this motor is 85% also. So what will be the required? Like the total battery pack capacity. So I calculated the battery pack capacity. So 4200 divided by 0.85 for battery and this one is for the motor. So I will be getting approx 5.8 kilowatt hour. So I think you are clear with it. Anyone have doubt in this calculation? So this much power of battery pack I required, like for this vehicle, for a vehicle of weight this one, and the speed of 50. Please mute. So anyone have doubt? Anyone clear with it or anyone have doubt? We can leave or we can proceed.
Sir, point number 8, battery and motor efficiency, how you are taken? It is assumption only.
Yeah, efficiency, yeah, from the data sheet of the battery or the motor we can get like how much efficient that motor is. So on that data sheet we can get this efficiency data, and then after calculation like the power required for like the expected distance range, and then we can divide that by this efficiency, and then we can get the required, like this much will be required for our particular like for our vehicle. So this is how.
This slide.
Yeah. Yes.
Can you share?
Slide. Okay. So wait. The session is not over yet. So I will be also discussing few things on the MATLAB. So any doubt in this part?
No,
So
slide.
no. Okay. Now so is my screen visible?
Yes, sir. Yes.
Okay. So this is the MATLAB in which I am showing some demonstration of the battery, like what happens. So please everyone view. So
Sir, not.
Yeah, any questions?
No, continue.
Okay. So this is the simple basic thing I am showing on the MATLAB. So this one is the battery which we can use, which we can get from the library browser, or we can simply double click on the screen and then we can get the battery. Sorry, this battery. So this is how we can get the battery. And now what I have done, so this one is my register series RLC branch. So I have connected a load to this battery, and this one is my bus selector. Like bus selector. Yes.
Hello.
Yeah.
Sir, screen cannot be screen.
Okay. Screen is not visible.
Yes, sir. Your screen is not visible.
Yeah. Now is it visible?
Yes, sir.
Yes, sir.
Okay. So this is the MATLAB demonstration. Yeah. Anyone was saying something? Okay. So this one is the battery model. So I can simply type the battery, and then I can get this model. So what is the port? This is the positive part. This is the positive terminal. This is the negative, and this is the measurement port of the battery. So I have used a bus selector here, or through which we can see the data, like what we require in the battery, like SOC, the current and the voltage, like how much current is being drawn from the battery. I simply set the voltage of 12.6 volt and the rated capacity of 5, and I have made the initial like 50% of the charge. SOC I have make it 50%. So when I connect this battery, so this is my load. This RLC branch shows me the load. So when I connect the battery to the load, what will happen? Can anyone tell me?
Power distributed.
Yeah, power will be distributed
Yeah.
or the battery SOC will be decreasing. So when I run this model,
That is discharge gate.
battery will be discharged. So I am running this model for 10 seconds. Okay. So you can see that here the current is start decreasing and also the battery, I have made the battery SOC at 50%. So we can see that the SOC of the battery start decreasing. Okay.
Can
So,
we visualize that one?
Yeah, what sir? Is it visible?
How much SOC can discharge?
So for 10 seconds I have
Now you are running the executive model.
yeah.
Now you are running the model. So can we visualize that how much percentage SOC was decreasing?
So I have put it here initially 50%, and then after that, like I assume that this model is initially at SOC of 50%, and then after that I have connected my load, and then I have set the value into it, and then I can see that it start decreasing. So for 10 seconds I have run this model to run, and we can see from 50 to till 49 it has been increased. Decreased. So this shows that the battery is discharging. So this is the battery connected with load, and then this one is the connected with the source. So so if we connect the battery with the source, so what will happen? So it will be start charging. So earlier when I connected it to the load, so we can see there that the battery was discharging and its SOC was decreasing. So here the nominal voltage I have kept of 12 only. Okay, and here so for charging the battery I have to keep the potential more than 12. So I have kept here to 14. So when I run this model, I already run this model. So we can see here that it will start increasing.
So we are unable to see the scope results.
Yes, they.
We are unable to see the scope results.
What did you say? To run the scope, I didn't get it.
The graph is not visible.
The graph is not visible.
Yes, sir.
Wait. Is it visible now?
Yes, sir.
Wait. So for this one, when I connected with the load, so this was on my graph. Okay, so we can see when I connected, like when the battery came to the discharging, we can see there is a decrease in the SOC, like 50 to 49%. The SOC decreases, and we can also see there is a dip in current as well as the voltage. Now, when I came to this, when the battery is connected to the source, so we can see we can see that there is this like my battery SOC start increasing. Like when I kept it at 50%, so after that when you connect with the voltage source, it start increasing, and its current is in negative direction which represent that the current is flowing inside the battery, and according to that the battery is being charged, and also we can see there is change in voltage. So I hope you are clear. And this,
Yes, sir.
okay, so this is my charging and discharging model. Right. So what I have done here, so this is the MOSFETs, okay, and this is the RNC branch. So I have make a bidirectional converter and convert, like we can say it is acting as a switch or which bidirectional converter here. So what I have, this one is my load and this one is my filter, and this is my gate pulse like 2, and this one is the source. And this one, this algorithm I have used for constant current charging, like for charging by 3 method we can charge our battery, constant current, constant voltage, constant current and constant voltage. So I have used here constant current, so I have connected this current port, and using the PID controllers and this PWM generator I generated the pulse, and after that it is being given to these converters MOSFETs and for the operation. So here 0 and 1. So when I put the 0, so this charger, this battery source is not connected to this part. So when the battery source is not connected, so what will happen? So who will say? When I disconnect this source, battery source, what will happen?
Charging source. After charging, source disconnected.
Like, yeah, if I disconnect this, I didn't have this source. So I have put it here 0, that means this switch is not turned on, it's turned off. And this one is my load, and this one is my bidirectional converter. So what will happen?
Battery discharge.
Battery discharge. Okay. So I am again running my model. So from here you can see that the so I have make here the nominal voltage. Let it change. So we can see that when I disconnect, when the battery is connected to the load, the SOC of the battery start decreasing, which means that the voltage, the battery is discharging. Okay, so SOC decreases, that means battery is discharging. Now when this is my switch. Okay, so when I give pulse to it, like when I make it 1, now see change in the current. What we have. So we can see that there, like what happened when I switch on this circuit now, this battery source came into the figure, and then what it does, it start charging the battery, like this bidirectional. Initially the current was flowing in this direction, now the current will start flowing into this direction, and then this battery will charge. So when I switch to when I switch to charging state, we can see there is a change in the SOC. Like now my SOC start increasing instead of discharging. I hope you are clear with it.
Yes.
Okay, so this was my battery charging and discharging explanation. So if you can have any doubt, you can ask, or we can end the session.
Sir, what is the basic knowledge required for MATLAB and SIMULINK? Can you just What is basic knowledge learning for
learning knowledge? For learning MATLAB,
what is
you should. Yeah,
what is basic knowledge learning for required learning for MATLAB and simulation?
So you need like the background of these things. Like if you are running on SIMULINK. So you should know the mathematics behind it, like what is the mathematics going behind it. So like for your reference, if I'm saying that I have to design a buck boost converter, so buck boost converter, you know the buck converter or boost converter, like DC to DC converters. I'm taking a just example. Hello?
Hello, sir.
Yes, sir. Yes, sir. Your voice.
So from that you should have the basic mathematics like the formula and the things. So and also know the circuit diagram of that. So
I can normally calculate the mathematics calculation in MATLAB.
you can also do that. Like you can connect the addition plus. You can use the summer adder, and then you can create your own equations, and then you can calculate it.
Yes, sir. And what can we do in simulation, sir?
Simulation like MATLAB has two things. So this one is for the coding part, and the simulation is here. So like this, if you are designing this one is the battery. So I have used the components here. So if you want to design any like I'm telling inverter, or you can say the choppers. So you should know the basic circuit of that chopper or the inverter, and after that you start. Like MATLAB has library in which many components are there, and you can use those components to design your own you can say inverter or a chopper, and then you can use them for your MATLAB model. So we can see here there are lots of components we can use.
So simulation is like virtual.
Yeah.
Simulation is like virtual lab.
Yeah. You can say it is a virtual lab.
Okay, sir. Thank you, sir.
Virtual lab.
Sir, I have a query.
Yeah.
Sir, the query is, see, we have the for the lithium-ion cells, we have the voltage nominal. We are using the nominal voltage is 3.6 like that. Right?
Yeah.
See, when I put the cells in the charging and discharging, again the cells will reach out the nominal voltage, right? After completing their charge and discharge, it will come to the nominal voltage, right?
Yeah. No, when like you can say.
Sir, 1 minute, sir. I will give the clear explanation. See, first I am completely discharging the cell voltage. Cell end voltage is at 2.5 or 2.85. So when I am completely discharging the cell, it is come to 2.5. Then I want to charge my cell up to 3.72. See, I required cells to be charged like 3.72 in the stage. It is getting charged at 3.72. Once it is reached the voltage value of 3.72, the program will complete. Like the cycle will complete. Again, what will happen? It is not completely in that
like
3.72.
if you have the playlist.
Sir, let me complete. When 3.72 completed, what it will happen? Again, it is going to the sum of the voltage. It is not holding in 3.72. We cannot hold that the voltage, right, sir? Even it is charging also.
Yeah. So what are you trying? Like you are saying that it will be maintained at that voltage, or it will be changed. You are trying to.
Yes, sir. Sir, I want to try to see, sir.
Yeah. There is a self-discharge phenomenon. So what happens when you, because of self-discharge, there is a decrease in, like it is a phenomenon which happens in every battery, like in lead acid, lithium metal hydride, and the lithium ions. So what is the thing is that in lithium ion battery, so that self-discharge rate is very low as compared to the other chemistry. So if we fully charge the battery and you left it, so there will be decrease because of this self-discharge.
Sir, again, I want to keep my voltage. I want to keep my voltage at 3.72. My nominal voltage is 3.7, but I want to hold that voltage is 3.72. What I need to do? What is the cycle parameter?
You
What is the
need to
recycle?
electrical charge. Electrical charge.
Yeah, that
Electrical charge. Electrical charge is a slow charging process.
Sir, sir, what is
You can ask or you can.
sir, what is the need of battery modeling of MATLAB and SIMULINK? Means why it is required to
Because like
do that?
wait. Suppose I do the calculation, I design my own way. Now I have to design the battery pack. Okay, so what I will be doing, I will be at first taking that model. I will be designing that model and do the simulation. What I will do, I will be adding the parameters and components, and I will start changing those values. So after getting the accurate result, like what we do in case of practical things, if I start checking, so lot of time what will happen, the component we need to buy more components, so it will make it more costlier. So initially what we do, we make it onto the software, and after that we get the confirmation that this component is suitable, that this value of this particular component is suitable. Then we can go to the hardware model. Okay.
Okay,
So
sir.
that's why important is that.
Okay, thank you.
Okay, so we can conclude.
Sir, one question.
Yeah.
Can a mechanical person upgrade to EV? So can require MATLAB and simulation is compulsory?
Yeah. For simulation, like you have to go for R&D field, you need to learn simulation.
Okay. Thank you.
Okay, we can conclude the session.
Yes, sir.
Okay, thank you everyone.
Sir, when we get the certificates and how will we get the certificates, sir?
You will get it very soon. Apart from the certificate, do you have any queries? Do anyone have any queries?
How can we know the any other webinars? Can we know? Any other webinars is held by your organization? How can we know? Okay, how can we come to know about it? Through mail or we should check your website?
Yeah, you can check on the ISI India's website. And there is one more thing I want to inform. Yeah, there is one more thing I need to inform to the students. Like, we are going to conduct a 2 days workshop on EV battery pack and battery management system itself.
Okay.
Yeah. So this is going to be the paid workshop, and it will be for 2 days. And we'll cover total 10 hours. I'm sharing. Yeah.
Okay, sir.
Yeah, it will be for 10 hours, and on 16th and 17th of January, if anyone interested in joining the workshop, they can fill out the forms. I'm sharing the form link in the chat box. You can find it there, and it's going to be paid, and the fees is very low. It's 835 rupees for 2 days workshop. So interested candidates can register themselves so that they can get the meeting link. And after our
Online
session,
या offline?
yes sir,
Offline या online?
it would be online.
Okay, sir.
Yeah, and
Sir,
Is there any demonstration of batteries?
yeah, you will get everything, every detail about the battery pack and battery management system. We have some topics going to be covered in that. For example, like we'll be covering the constant of cells, types of cells, cell pack designing, grading of cell, BMS introduction, BMS Indian content, and many more things. You'll also get some hands-on learning, and at the end of the session, after 2 days, you will also get the certificate from our side for that 2 days workshop. So if anyone who is interested for the workshop can register through the link I have shared in the chat box. Please check the link.
So what is the type of payment we need to do, sir, for registration?
Yeah, once you are done with the registration, you will get a confirmation mail from our team, and with that we'll also send you